So,
So, good afternoon, sir. We are the Group 5, the course Mtec 102, period semifinal, week 1, session 1, and the topic for today is radar plotting. So, next slide. Course outcome: solve and perform manual plotting techniques given the information from the radar observation. So, learning outcome: at the end of the session, the students shall be able to first define on how the marine radar works. Second, familiarize the basic components of marine radar. Third, determine the radar errors. And lastly, perform manual plotting techniques given the information from the radar observation. So next slide. So the importance of topic. Next slide, please. So how does marine radar works? The term radar is an acronym for radar detection and ranging. The marine radar works on the basic principle of electromagnetic waves. The radar antenna sends the high-speed electromagnetic waves to establish the location, which is the velocity and the direction of the wave traveled, along with the altitude of the object moving or stationary. So radar works by transmitting radio waves or radio signals into a certain vessel. So next slide. Next slide. So let us understand how does the marine radar works. The radar system out electromagnetic waves as a high-speed signal which will travel several miles into the direction of radar facing. If there are no objects in the wave, the radar screen will show blank. So if there is an object which will reflect the wave back to the radar, the computer setup of the radar will determine the distance between the ship and the object along with its location. Hence, it can be said that the radar basically reads two things: the position of the object and the direction of the same position of the object. The radar antenna is the continuously rotating on the top of the ship, sending and receiving signals. Hence, the radar is sweeping the signals all around the ship. As the radar pulse waves are reflected by an object, it will travel in that same direction and will be received by the radar detecting the position of the object. When the pulses are received back, the computer screen will lag the position. So the next reporter will be Kurt Hinayon. Kurt.
so this is the illustration. Next slide. So, as you can see, distance from the ship, as the radar antenna is constantly sending and receiving signals from the object on the way of the electromagnetic signals. The received signal is sent back to the computer unit, which calculates the time taken for the signal to reflect back to the radar. Once the computer knows the time, it will calculate the distance by using the speed and time formula. So this is the illustration. So the peak one is the speed of waves or AMS and time taken to receive the reflected signal. So to get the distance is simply A times B. Next, marine rate marine radar diagram. So here are the basic components of marine radar are shown in the below diagram. So here in this illustration, there's the antenna, waveguide, and then there's an object far away, and then to transmit uh, is using electromagnetic waves. So there's a receiver, there's a signal processor, master clock, modulator, transmitter, and then finally, it will show in the radar screen as an object. Next, uses of marine radar. So the uses of marine radar is to calculate range and bearing of a target and thereafter use the information to determine speed, course, etc. So if you can see an object far away, so uh, in the radar you can actually get the bearing and the range of the specific target that you are getting. So number two is integration with other shipboard equipment such as ECDIS to derive precise data. So in radar, we can see the objects that are around us depends on the range. And so with the integration, you can also see in the ECDIS the other objects that is around your ship. So number three is navigating on vessel and her course with regards to collision avoidance. Number four is fixing the ship's position using terrestrial objects such as lighthouses, buoys, etc. Number five is differentiating between targets in high traffic density areas. And six, determine of the weather to an extent. Next. So what are the possible health effects of radar? So most studies conducted to date examined health effects other than cancer. They probed into physiological and thermoregulatory response. So behavioral changes and effects such as the induction of lenses, opacities, cataracts, and adverse reproductive outcome following acute exposure to relatively high levels of RF fields. There are also a number of studies that report non-thermal effects where no appreciable rise in temperature can be measured. Next. So cancer-related studies, many epidemiological studies have addressed possible links between exposure to RF and excess risk of cancer. However, because of the differences in the design and the execution of these studies, their results are difficult to interpret. So, a number of national and international peer review groups have concluded that there is no clear evidence of link between RF exposure and the excess risk of cancer. So, WHO or the World Health Organization has also concluded that there is no convincing scientific evidence that exposure to RF shortens the lifespan of humans, or that RF is an inducer or promoter of cancer. However, further studies are necessary. So this is an illustration of skin cancer. Next reporter will be JV.
Next, heading. This is a one. First, heading marker alignment. Second, ABL not alignment. Third, gyro input with error. Fourth, improper range. Six, blind six door. Seven, adjustment, rain cut, clutter, sick clutter. Eight, on vessel date input error. Nine, range and bearing discrimination. 10, beam with distortion. 11, side lobe echo. 12, multiple echo. 13, second trace echo. Next. One of the limitations of ship radar is that it may not be able to detect an object due to its size, proximity to sea surface, or when the object is a poor radar target because of its construction or design. For example, military ships are designed so that radar waves do not reflect back to the receiving unit of the radar scanner. This is also happens with wooden fishing boat as they have poor radar reflective surface. Small unit boats engaged in fishing are also difficult to sight visually at night. Sometimes they may not be seen during daytime from the bridge due to height or the angle of viewing or reflection of the sea surface. When navigating in the proximity of such vessel or their known operating areas, it is good practice to post an alert lookout with a walkie-talkie on the forecastle deck. Next, the next is the illustration. In the in the following picture, say in the following picture, seaweed is giving very good radar returns due to the highly reflective surface. It had covered the whole sea surface during low water, but because it was the ship first called to port area, which which was not well surveyed, my first thought was that there may be an error in the charts and we altered course to stay well clear. We started approaching only after getting positive confirmation by all possible means that it was safe to do so and there was ample water with sufficient depth. It is always better to be safe than sorry. I was also concerned if the seaweed, because of being so densely packed, could in any way foul the bow cluster. Next. The next is the illustration. This it could be appear that vessel very close to shore line. This, next. The next is radar ARPA performance standard. And this is the illustration. This is the illustration kuan sa size of shipcraft ang GRT ang mga gidakon naratan lang diri yang TIS capacity target. Next, ah, that's all there. Thank you.